So, hello everyone. Like you mentioned, I'm Aishwarya. I'm from Tesla. And today I'm going to talk about one of the projects that we at Carnegie Mellon University, we were pursuing this since 2022. So imagine a hurricane has hit your town. Everything is devastated, houses are destroyed, there are power lines everywhere, and you're trying to make your way through this extremely dangerous and unstable land. Now imagine doing that while you have no sight. Our world is like filled with gaps. Some gaps are small and temporary, but others are much more longer lasting. For the blind, it's never ending. So in this situation, like for a real user, how would you know when to cross a street when the light has turned? Or when your cab driver has dropped you off, how do you find the entrance to a building? So that's where we are trying to make the world just as easy as it is for sighted human beings. Can we do the similar things? So can we take visual sensory inputs, and can an AI app in real time predict how a sighted human being can react to this? And then convey this prediction to the blind individual audibly. So our research project started in 2022. We began with very basic aspects of this. We had initially partnered with Microsoft Seeing AI app, and that app was more general purpose in order to perceive the world. We are targeting more towards how to improve navigation in a real world for a blind user. Throughout this presentation, I will walk through our overall strategies, the constrained environment that we work through, our data collection processes, our modeling pipelines, and some of our results. The environment that we walk through is kind of very constrained. For example, there's a lot of research that's going on for self-driving car. Tesla has a huge team, I'm part of that team, and we have lots of resources to work on it. And for a car, it's quite easy if you think that you have navigation systems. Obviously, it's not that easy, otherwise I won't have a job. But like for a car, you have navigation GPS signals, and you want to work according to those GPS signals to reach an end goal. Blind users have similar GPS information, and they have their cane for mobility skills. What they do not have is fine-grained information telling them when to take the turn, when exactly to cross the street, or where exactly to find the entrance to a building they want to enter. Could we have an AI model that can take these high-level intent instructions and transfer them to like fine-grained directions?